Okay, this series of next sections, we looked at plugging stuff into the equations. Now we're looking at not necessarily plugging something in. Well, we're still plugging it in, but we're plugging it in for y instead of up here plugging it in for x or whatever. So if we're plugging 125 in for basic, technically y of the k equation, we're saying that x to the 3/2 power is equal to 125. Okay, if that's the case, and it's the same thing we're doing over here, if I raise both sides to the reciprocal, what that's going to do to get x by itself, which is our goal, that's going to cancel each of these, but I just need to make sure I keep the equation balanced and do that to both sides. So the math related, I mean, these cancel, so there's not a lot going on there. The math related to this problem then is taking 125 to that fractional exponent. And as we've been doing all along, we're going to start with the bottom. Because, yeah, we could square 125, but you're getting into a big number. This is going to keep things a little more familiar. The third root of 125 is equal to 5. Okay, so if we just take that portion of it, I've got a 5. That's been done to that, turning it into that, but I still have that 2 left over. So I've still got a 5 squared left over. So x, the result, is just 5 squared, which is equal to 25. Now, the burden of proof, when I ask you to prove it, it comes down to, well, how can I do that? One thing is you can show your work, as I've done here, but the proof sometimes means you got to go a little bit extra. What can I do to 25 to turn it back into a 125? Well, if I show that I'm using that equation, which you can barely see, the equation from the original function, if I take 25 and raise it to the 3/2 power, and it turns it back into 125, then I'm saying, well, if I do that to this, I get that. Okay, and so we can do it in pieces, and I can break it down kind of like I did before, but the opposite way now. First things first, if I take the square root of 25, that's going to give me a 5, and if I raise it to the 3rd power, that's equal to the 125. So it's 2 problems in one again. Square root of 125 is 5. And I meant to do this. I'm just going to do it. So there's the 5 that would be inside the parentheses. And then the outside still yet to do, that is equal to the 125. So there's proof in terms of turning the answer back into that by using the function in question. So, I'd kind of like to do this when it looks bigger and uglier than it really is. Referring back to that function g, or I guess it would be h. H is asking us to take the equation x to the 6th power. Say that's equal to 15,000. I have to slide it over. 625. Well, it ends in a 5, so there's your hint. But something raised to the 6th power is equal to this big ugly number. Well, one thing you can do is raise it to the 1/6 power like we did earlier. Find that x is equal to actually 5 after you do a little bit of work. Fortunately, I didn't ask you to prove it here because that would get pretty intense. But why are there 2 answers? And I've only shown one so far. So if I put that there, let me ask you a different question. Go back to this. When you say x squared is equal to 25, we kind of get used to looking at that and saying, oh yeah, the answer is 5 and -5. Well, by the same sense of logic, you've got x to the 6th power. And the key thing is any number raised to an even power should have 2 answers if you solve it in this way. It should be the positive and the negative answer. So that's that. Okay.